Hi friends, welcome back. After looking at the different types of arrays like one dimension, two dimension, three dimension, or in general n dimensional arrays, let us look at another important and very commonly practically available arrays which we call a sparse array. Sparse array generally is a special type of array wherein a majority of the elements are zero, very few elements are non-zero. So when we have very few elements, a non-zero, and the majority of the elements are zero, then the way we represent this information to any other human would be just say the size of the array and then say that most of the elements are zero except few, and we just refer to the indices of those elements which are non-zero and say that these elements are non-zero having these values and rest all are zero. So that's how we keep telling. So instead of reading this shown matrix as an example, which contains 5 rows and 4 columns, that is in all 20 elements. Instead of reading these elements as 0, 1, 0, 0, 0, 0, 0, 0, 0, 5, 0, 2, 9, 0, 0, 6, 7, 0, 0, 0. So it is time consuming, and we can see that a lot of space also is unnecessarily used to just represent zeros. So we could reduce the whole representation, where we can change the representation of this particular situation and try to reduce the time to convey the information as well the amount of space used for doing so. So instead of telling all elements one by one, in I could say that we have a 5 by 4 matrix. Most of them are zero except row 1 column 2 has an element 1, and row 3 column 2 has a value 5, and row 3 column 4 has a value 2, and uh, row 4 column 1 has a value of 9, and row 4 column 4 has a value of 6, and row 5 column 1 has a value of 7. The rest all are zero. If I can tell that, I can speed up my communication so I can communicate all the information in lesser time, and I can put that in this new representation where only the non-zero elements are represented and say which row, which column, what number is there. So we just have to use 6 rows for this. So instead of 5 by 4 having 20 elements, instead of speaking 20 elements, we can speak of 6 by 3, only 18 elements. So we could reduce a small here, but this is just for an example. But in normal situations, we won't be talking with these small matrices. We will be talking with a bigger matrices like maybe uh, matrix of bigger size. So if we can take up this way, we are going to save time as well as memory. So example can be another example we can take up, which is of a bigger size, and very few numbers you can see are non-zero, rest all are zero. So if we talk of this sparse matrix, then if there are, say, we are talking of a matrix of 100 by 100 size, then there will be 10,000 elements in the matrix, 10,000 elements in the matrix. And if we assume that there are only, say, 100 non-zero values in this 100 by 100 matrix, then this 100 by 100 matrix can be represented by a row number, column number, and its value. So we require three columns, and there will be 100 rows, one row for each of the non-zero element. So instead of 10,000, we could have stored only in 300 locations. All the information can be stored. So we are saving so much of space, and also lot of time is being saved. So instead of 2D, if we had a 3D and each dimension was of 100 size, then we are talking about 100 by 100 by 100 3D array. Then in all there will be 1 million elements. And if you assume that only 1,000 elements are non-zero, then because of three dimensions, we require three columns to represent each of the dimension position, and one extra column for the value. So in all, if there are 1,000 non-zero elements into 4, so maximum 4,000 values we need to store to talk about this 1 million sized matrix. So that way we are going to save a lot of size. So in case of any table, in case of any sparse array, the table size required will be n plus 1, where n is the dimension of the array, plus 1, because that's the new column. We'll be talking about the value of the element. So n columns for n dimension indices and one column for the value. Then these are the number of columns we do have, and the number of non-zero elements will be the number of rows. So in all, n plus 1 times number of non-zero elements will be the table size required. So if we are making use of this new convention, definitely we are going to save a lot of time and a lot of memory. So that's all about the sparse arrays.